Hi friends, here in this video we are going to see how to draw a cam profile for a knife edge follower, and for that here is the question. I'll read the question and write the data along with it. It is given a cam rotating at uniform speed is required to give the knife edge follower motions as defined below. So first thing which is highlighted here is the type of follower. The type of follower is a knife edge follower. It can even be roller follower, but in this case it is knife edge given, so I am mentioning the type. Next, motions as defined below. Follower to move outwards through a distance of 30 mm. It means the follower is covering a height of 30 mm. That is called as the lift or stroke. Lift of follower or the stroke of follower. Then, during 60 degree of cam rotation with uniform velocity, that 60 degree is the out stroke, denoted as theta out, and it is with uniform velocity. Then, follower to dwell for the next 30 degree of cam rotation. That is the first dwell given. Then, follower to return to its original position during next 60 degree of cam rotation with uniform velocity. So again it is returning by covering an angle of 60 degree, and that is also with uniform velocity. So this is the follower motion given during both outstroke and return stroke with uniform velocity. Next, the minimum radius of the cam is 25 mm. Then, draw the profile of the cam when the follower translates along the axis of the cam. It means the axis of the follower and the axis of the cam are in line. So that is a type of follower called as inline follower. So here we have an inline follower, which is the knife edge follower. As mentioned over here, inline knife edge follower. Now, in some problems it may even be an offset follower, that is the axis of the follower and the axis of the cam are not passing through the same line. It can be followed with some distance, so also called as the offset follower. Now with this data available, we can easily start the problem, and when I am starting the solution part, the first step would be to draw the displacement diagram. So in the solution, step number 1, displacement diagram. Now displacement diagram needs to be drawn considering uniform velocity as mentioned in the problem. The lift is 30 mm. So for that, drawing a light vertical line. After drawing this light vertical line, whatever I am drawing with green, that would indicate the light line, marking 30 mm over it. Drawing light horizontal lines. So this is the stroke of 30 mm. Then outstroke is given as 60 degree, and that outstroke I am going to plot it over this horizontal line considering 1 centimeter is 10 degree. That is, since it is 60 degree, it would fit into 6 centimeters, and dividing it into 6 equal parts. Outstroke is 60 degree. I'll give the notations over here. starting with 0, first, second, third, fourth, fifth and sixth. So these are the 6 divisions. I have taken 1 centimeter as 10 degrees, so it is 60 degree which will fit into 6 centimeters. Now in a similar manner I would be dividing this stroke also into 6 equal parts, that is for uniform velocity. Since it is 30 mm, so that would be 55 mm. Giving the notations. Now for uniform velocity, projecting 1 from the out stroke, light vertical line, light horizontal line from point 1 on the stroke or lift. The intersection point gives me the first point, then for second, next for third, fourth, fifth and sixth. So these are the points. Joining them with the help of a line, which is an inclined line. So this dark line indicates the follower rise during 60 degree of cam rotation, which is the out stroke, and during that I'll just explain that the follower moves up from 0. This follower movement which I am showing here need not be shown onto the displacement diagram. This is just for an explanation that how the follower moves up during the out stroke, and it will reach the final height of 30 mm when the out stroke is completed. Then after that there is dwell for 30 degree, and for dwell we need not divide it into equal parts, because at the dwell the follower will remain at the same position when the cam rotates. First dwell given as 30 degree. Then after that there is return stroke of 60 degree. So in a similar manner like I have divided the out stroke into 6 equal parts, I'll divide the return stroke as well, taking 1 centimeter as 10 degree. And giving the notations here as well. For simplicity, I'll give the notations in the reverse order for the return stroke. So starting with 6, it is 5, 4, 3 to 1 and 0. Then after that, when I add up the values, this gives me the answer as 150. From 360, when I subtract it, I'm going to get 210. So it is dwell for the remaining 210 degree. And that dwell need not be shown in a complete form. It can be just shown with the help of a broken section. The second dwell of 210 degree. Now I'll plot the return stroke. For that, this 5 would be projected up and projecting 5 horizontally from the left. Next 0.4. Similarly the remaining points 3. 0.1 and 0. So connecting all these points, that is 6, 5, 4, 3, 2, 1 and 0 with the help of a line. And to explain it, here it is dwell for the 30 degree after out stroke, and then there is return stroke and dwell for another 210 degree, which is the second dwell, and the follower will start falling from its position during the return stroke with again uniform velocity as given in the problem, and finally the follower will return to its original position. Now here we have completed step number 1, that is the displacement diagram. Step number 2 is the cam profile. First, I'll draw light horizontal and light vertical lines. Light horizontal and light vertical lines. Next, starting with the minimum radius, which is 25 mm, I'll measure 25 mm in the compass. So taking 25 mm and drawing a light circle. Here in green, whatever I am using, that indicates the light line or the light curve. So this is the minimum radius of the cam. Then, as mentioned in the problem, it is an inline follower. So the axis of the follower will be this vertical axis, and axis of cam is this single point. So I am just drawing the knife edge follower, which will be in line. So this is the knife edge follower in line, and here the reference point I am marking it as 0. And in the question, when we see, the rotation direction is not mentioned anywhere, that is whether the cam rotates in clockwise or anti-clockwise direction. Since nothing is mentioned, I am assuming that the cam rotates in a clockwise manner, and whenever the cam is rotating in a clockwise manner, we have to take the angle or measure the angles in an anti-clockwise sense, because that would give us the correct motion. So here I'll explain that first I am measuring for the out stroke. It is given as 60 degree. So here is the reference point. Measuring 60 degree in an anti-clockwise sense because the cam rotation is in clockwise direction, and dividing this angle into 6 equal parts of 10 degree each. Plotting light lines. Plotting the light lines. Now, I had divided this out stroke into 6 equal parts in a similar manner like I have done in the displacement diagram, and in order to make the problem more simple, giving the notations to these angles as well. So starting with 0 so that it becomes convenient for us to plot the points. Then first, second, third, fourth, fifth and sixth. So I have given the notations. Now this is the base circle. Point O is the initial point of the follower, which is in contact with the cam. Now, in order to plot point number 1, I am measuring the distance from this point 1 on the out stroke up to here. That is, this is the height. And then, with the help of this base circle, onto the first notation, keeping the point on the base circle, I am marking a point on this first division. So I get point number 1. Similarly, point number 2 would be measured vertically onto the out stroke from the base circle on the second division. This is point number 2. Then point 3rd. Next point 4. Keeping on the base circle on the 4th division, marking the point. Next point 5. Then finally point 6 onto the base circle. Now all these 6 points are to be connected with the help of a curve, and drawing a light curve first, connecting all the points. So drawing this light curve, then after 60 degree, this is the out stroke indicating 60 degree of cam rotation. Then there is a dwell of 30 degree as mentioned. So since this angle is 90 degree, already 60 have been measured. So whatever remains is 30 degree, which is the first dwell. And now I am giving it the same notation, that is point number 6, this division for the dwell. And the dwell is having the same height as we can see here, where the outstroke ended. Dwell is also having the same height. So keeping the same distance from the base circle, I'll plot the point over here, and with the help of this center, which is the center of the base circle, I'll draw a light arc connecting the points. So this is the dwell period. Then after that, there is return stroke of 60. So again, I'll be measuring 60 degree and dividing it into 6 equal parts, like I have done for the outstroke. Taking 60 degree and dividing it into 6 equal parts. So I have divided the return stroke and giving the notations in the reverse order, like this is 6. So here this would be 5, 4, 3, 2, 1 and 0. After point 6, it is returning. So measuring the distance from point number 5, keeping on the base circle, cutting this division of 5, next 4, measuring this vertical distance from 4, keeping on the base circle, cutting the division, which is the 4th division, then 3, keeping on the base circle, cutting the division, then point number 2, then point 1, cutting the line passing through 1, and finally it will reach up to this point, which is again indicating the initial position, which is 0. Now joining all these points in order with the help of a smooth curve, first drawing it light, and now I can make it dark. So I'll make it dark. And then it is a circle for the remaining position. That is the remaining dwell period. It is 210 degree, that is the remaining dwell period, and finally I can draw the axis with the help of center line. And here if we want, at the center we can show a shaft. This is just an option with the help of a keyway. And when this shaft rotates, the cam starts rotating. And here, as it is rotating in the clockwise direction, I had said in the problem to measure the angle in an anti-clockwise manner. So we can see from 0, when this starts rotating, 1, it would be following the exact motion. So whenever the rotation is clockwise, measure the angle in an anti-clockwise sense. And similarly, if it is an anti-clockwise rotation, take the angle onto the clockwise direction, that is onto the right hand side. So finally, Once we have reached up till here, this is the base circle, and here we have the knife edge follower, and the radius of the base circle was given as 25 mm, so its diameter would be 50 mm. And with this the problem gets completed. That is, we have drawn the cam profile for the knife edge inline follower. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.